So this video is on definite integration and area under a curve. Definite integration gives a number answer. So unlike what we have been doing currently with integration, where we get an equation as an answer, this time we will actually get a solution. Now to do this, we have to have some boundaries. And you'll see in this first example what those boundaries are. So here we have evaluate the integral from 1 to 4 of x cubed dx. Now those boundaries are the two numbers that you can probably guess, 1 and 4. So these are the boundaries. So this is telling us that we want to evaluate this just between the x values of 1 and 4. Now I'm going to go to the calculator and show you how this works. You don't need to be able to do this by hand, you just have to do it on the calculator. So on the calculator, go to just a normal calculator page, press menu, number 4 calculus, and then number 2 numerical integral. Here we just put in exactly as the question looks, so our boundaries from 1 to 4, and our equation of x cubed dx. Press enter, and you will see that our answer is 63.75, and it's that easy. Our integral from 1 to 4 of x cubed dx equals 63.75. Now when we've looked at derivative, we know that gives us the gradient of the tangent. What a definite integral gives us is the area between a curve or a straight line or the graph and the x-axis. In the diagram here, you'll see our boundaries of A and B, either side of the area we're trying to find, and the red shaded bit is the area, and that's what the integral actually helps us find. So example 2, we have here find the shaded area. And we want to, first of all, we want to write our integral and our boundaries. So boundaries go from the origin, which is 0 to x equals 1. It's where our area goes from, and then we just have our equation, which is there, x squared minus x cubed dx. And now from here, we just go to our calculator and work it out from there. We need to go to menu, number 4 calculus, number 2, just put in our information. So it's going from 0 to 1, and our equation is x squared minus x cubed dx. Press enter, and the area is 0.08333 recurring. And there we have our answer. Now example 3, I've just got a bit of a worded problem for you just to see how it can relate to some different things. Water is dripping into a bucket at a rate of t squared centimeters cubed per minute after a time of t minutes. The volume in the bucket after 1 minute is 5 centimeters cubed. Find the volume after 4 minutes. Now the main bit to remember here, and the bit that tells us this will be an integral question, is we have a rate. Now I had told you this before with our derivatives. When we do the derivative, it's our gradient function, and it is also a rate of change function. So we're looking at how something is changing over time. So when we have a rate, it also often links to calculus. Now we know the volume in the bucket after 1 minute is 5 centimeters cubed, and we want to find the volume after 4 minutes. Now we need to look at what our integral and things is going to be. We have our integral. Now we know our equation is t squared, tells us that in the question. And we need to work out our boundaries. We know what the volume of the first minute is, so we don't need to look at that, but we need to know the rest of it to go up to 4 minutes. So we need our boundaries to be from 1 minute to 4 minutes. And then after this, we'll put dt, and that's because we've got t in our equation. If you put this into your calculator, as we've shown you previously, you will get an answer of 21 centimeters cubed. Now we've got this, we just need to add in our first minute, the volume in the bucket after the first minute, because this is from 1 to 4 minutes. We just need to do 21 plus 5, so our volume after 4 minutes was 26 centimeters cubed. And that's definite integration.